I'm actually from Trempealeau County. I grew up in near Dodge, which is very small. So in case all you don't know where it is, it's about exactly halfway between La Crosse and Eau Claire. I actually went to school in Arcadia, which is 15, 20 minutes away or so. And then after I graduated from Arcadia, I went to Notre Dame, got my degree in environmental science or environmental engineering and geological science. And hello, this is the hallway.
Cool.
And
down here if you want them.
then I slowed down for a while because I had a job all lined up. Ironically enough, it was a job with a mining operation down south. Not to do anything with the mining, they just needed somebody to keep track of all the other stuff they're digging through to get to the oil and gas. Mud logging, for those of you who are interested in the actual technical term. But then as I was getting the physical for a job, they found cancer, so I had to stay here and get treated for that in Rochester. Then they found cancer again a second time, I had to get treated for that as well. So I decided I was going to be here a little bit longer, started substitute teaching in Arcadia and Independence. And I also started volunteering, do a lot of work now for Castle Rock Museum in Alma, one of 3 medieval arms and arms museums in this country, so definitely recommend going if you ever get a chance. And then of course this whole issue came up, and it was just the reason I started doing more and more of this talking. Some of you may have recognized I've done a lot of stuff with Trempealeau County. I gave a presentation to the board on the day they voted. Well, tried to vote on the moratorium. It didn't go quite as well as we'd have hoped. It was defeated by an 8-8 tie. And I've done some with the Whitehall Film Festival, that some of you probably read before, and just other things along those lines. And the reason that I guess started doing this was twofold. First of all, I had a degree that was kind of right up the alley in order to actually understand what was going on, which was really beneficial. And I also knew all the proper places to start looking for research and information and stuff like that to kind of get the whole picture as to what was going on in the area. And second of all, it was just whenever I talked to people, just completely dumbfounded just how little information was circulating about what's exactly going on. So I just kind of was more, of course I am against the mine. I do not like the mining personally. I do advocate though that we don't necessarily have to get rid of it completely, but maybe try and slow it down. But aside from my own personal viewpoint, I'm really more interested in getting people to understand what exactly is going on and why everyone is so interested in the sand in the first place.
That's what we're all waiting to hear.
That's what you're all waiting to hear. So, along those lines, how many of you have a little bit of decent working knowledge of how geology works? Okay, that's good. About half of you. How many of you have a good working knowledge of the local geology of the area? A few less than, about half of the half. That's good. Well, hopefully this will just be sort of an overview, and for those of you who don't know, it'll be a chance to sort of get your feet in the water in terms of what's going on, why everyone is so fixated in this area. Well, geology is a big topic. It's not really a discipline, it's more of an umbrella term for lots of smaller disciplines, of which you have things like mineralogy, where people study minerals, petrology, where people study rocks. There's even some environmental science bleeds through, and then of course you can attach geo to pretty much every other science you can think of, and then you have a whole new field of discipline. So you've heard of microbiology, people study bacteria and stuff, right? Well, all of a sudden you put geo in front of it, then you have geomicrobiology, which is its own field of bacteria that are in the dirt. So it's a very broad term, and unfortunately, half an hour is not enough time to just go into the whole thing. So I'm going to try and introduce things, go through the history of the area and how the sand got here, introduce concepts as they come up. And if you become lost or I'm moving too fast or forgot to mention something, please ask questions and stop me, and I'll do my best to answer them. So, one thing that people don't necessarily understand, because I always get this question from my grandpa all the time, why don't we have any natural resources? He asked this before the sand, of course, became why now. How come we don't have oil? How come we don't have natural gas? How come we don't have coal? And I tell them the same thing all the time. It's because we're too old, which is a little bit of a mind-blowing concept for a lot of people, because people think of these, oil, natural gas, coal as being stuff that's formed millions of years ago, and it must be really, really old. And they're right, it is. But there's a lot of stuff that actually happened before that stuff even formed. Coal, of all those resources, coal is probably the one that's formed the longest ago, during what's known as the Carboniferous period, which is one of the stages of Earth's development. And this predates even that. Back when, if you look at me, if I were to stand here and I were to hold a pen that I have in my pocket and hold it up above my head like this, I can use my body as an entire map of Earth's history. So if the Earth is formed at the soles of my feet, traveling up here, I wouldn't even have life on the planet at all till above my waist. That's how long it took just for the first cells to kind of coalesce, a very simple prokaryotic bacteria cells. Long time for that to happen. I wouldn't even have multicellular life, so those bacteria didn't even clump together, didn't even form eukaryotic cells till like my shoulder. And then moving on from there, dinosaurs would have been about here and died out around there. And then people would be, if I were to take a millimeter sliver off the top of this pen right here, that'd still be too thick, or smaller than that even. So there's a lot of history in the Earth. It's a very, very old formation. Now the sand mining, in terms of place that in your mind chronologically, the sand would have been formed kind of around elbow area right about here.
How many billion years ago?
It's actually about 500 to 600 million years ago.
500 to 600 million?
Yes. So close to 500 million. What was going on at this time was the Earth was cooling down. It had formed oceans. Everything looked, it was very much a transition period. We're starting to get what we would get the big land masses that we would soon to call continents. However, they haven't quite coalesced into what continents we think of are nowadays. They're a lot more like islands. They're small, isolated chunks of rock floating in a very tall, very widespread ocean. And what would happen then is, as the rest of the rock kind of bubbled up from the surface from volcanic activity, tectonic activity, would smash it onto these other little isolated islands and build onto them and create the larger continents that we know today. So each of these little rocky islands formed a very dense metamorphic rock. Well, it was igneous and then became a metamorphic rock. These were called cratons. And cratons are basically the root of all continents. And we're very fortunate in a lot of respects because this whole sand mining area is kind of situated right at the edge of a craton. We're at the edge of where the North American continent began 500 million years ago. Well, longer than that, billion years ago or so. So that's the first part you have to remember. We were the edge of the continent at one time. We were basically where, kind of similar to what the Gulf Coast would have been like now. Right on the edge, right next to a very widespread shallow ocean.
Closer to the equator?
We were also, due to tectonic activity and plate movement and stuff like that, much closer to the equator. In fact, we were south of the equator. Believe it or not, North America is about, latitude-wise, where modern-day Brazil is right now. About 15 degrees south latitude. So we were not only smaller, we were also much further south and much more tropical. So if you can imagine those white sand beaches that you see down in Cancun and down in the Caribbean, it's kind of what it was like right here. We were a relatively small landmass, fringed with that really, really nice sand. And of course, this predates plant life, land plants anyway. So we had no plants in the land. There wasn't really anything in position. So you had constant wind erosion, constant wave action, nothing to really hold it back. Because of that, we ended up getting a couple things happening. We had most of the detritus, most of the stuff that gets stuck in modern day sand kind of got blown or washed away and left behind a very pure form of sand, very homogeneous. And also because of that, the crystals became very uniformly shaped. When you leave sand out exposed to the environment, it tends to all trend towards being the particles get to be the same size and same shape. Became very uniform. We don't see this very often nowadays because there's a lot of stuff getting in the way of erosion. There's plants, there's, well, mostly plants actually. People more to a lesser extent. So we don't see that quite to the extent that it used to be. There used to be this stuff just got eroded down so that it was very fine, very uniform. Like I said, it was very similar to a Caribbean beach, is what the Wisconsin looked like.
And what made it so hard, so unusual?
What made it so hard? Well, actually, one thing that I'm going to bring up here, and this is kind of one of those concepts that is a little bit bizarre for people to grasp, is sand is not really a thing. It's actually a size category. So when a geologist talks about sand, he doesn't mean like I'm holding beach sand. That's just one type of sand. Any substance that's a mineral and made of particles within a certain range of diameters is considered to be sand. So it doesn't matter if it's made of quartz, if it's made of olivine, if it's made of calcium carbonate, limestone, it doesn't matter. If it's within that, right, if it's smaller than gravel but bigger than silt, it's called sand. So that's one thing is when people say, well, how come everyone wants the sand in this area? Well, I mean, there's sand all over the place. The answer is yes, there is sand all over the place, but they're not interested. The fact that it is sand is only one part of the puzzle. The other part is what the sand is made of. If you look at most sands in the area, out of rivers and stuff like that, if you look at most sands and beaches, you'll see they got pebbles in them, they got smaller things, they got sticks. There's a very big range of stuff that's in there. If you break open the sand that they're mining and wash all of the binding agent off that holds it together into that rock formation and look at it, you notice that it all looks pretty much the same. It looks like very small, very spheroidal pieces of, it almost looks like glass. The reason for that is because the sand is mostly made of quartz. Now, most sand has a lot of quartz in it, but it also has a lot of other stuff in it too. It has small bits of biotite, it has small bits of calcium that gets washed into it. It has small bits of a whole bunch of stuff, whatever happens to be flowing in the area. And of course, has lots of organic matter as well. However, since this sand was so exposed to the elements, most of that stuff got washed away and was left with just this pure quartz. So, two things about it. First of all, the sand means that it's that right size category that they need to use in the mining. And second of all, the fact that it's quartz means that it's very hard to break. And the fact that they're all basically the same size means that they don't have any irregularities in the composition, which makes them, the engineers very happy about that. Then, of course, to add to that fact is the fact that we have multiple units of the stuff. We don't have just one sand formation. We actually have 4 mineable sand formations that they like to go after. The Mount Simon, the Waniwak, the Jordan sand, and the St. Peter, thank you. The reason for that is because of a little thing called Walther's Law. Now, what Walther's Law states is that anytime you have an environment next to an environment, that gets superimposed on it in the rock structure. So if I look at a column of rock and I see sand followed by silt, I know that at one point this was a beach or a lagoon. Because the sand was on the beach, but as you wade out of a beach further and further, you get deeper in the water, you get less and less sandy it's, right? You get more detritus from dead animals and dead plants kind of floating down to the bottom. There's not as much wave action because the waves aren't crashing against the shore. It's a lot more calm deeper in the water, so you get a lot more silt forming. So those are formations that form next to each other. However, back when the sand was being formed, 500-600 million years ago, the ocean was very unstable. The ocean level would rise and fall constantly. And to add to that, the continents were also very unstable. The continents were also bobbing up and down on the asthenosphere, the fluid part of the crust, constantly. So you had a lot of times during the history, this 100 million year history, where the ocean level would change and the coastline would actually change. So what would happen is we'd spend a long time as a beach building layers of sand. Then the ocean would shift, and then all of a sudden the coast would move much further inward. Now that same place is now, instead of being on the coastline, it's actually now out in the middle of the ocean. So now it's building a layer of silt. Then it shifts back. Now it's building sand again. So that back and forth action that allowed the terrain to change in relation to a fixed point in the Earth's sphere, that's actually what built these multiple units of sand. So we have the craton, the roots of the continent. And then throughout the course of a very long time, about 100 million years, we had sand and silt being tacked onto the edge of that craton because that's where the beach used to be, building on top of each other these layers of sand that we're now trying to mine for, for the use of a proppant, for the fracking process.
We're not trying to mine them.
We're not, personally. As somebody, some entity is trying to mine. You're right. So, because of that, that's why everyone's so focused on this area, because it's a very unique situation to what anyone else in the country has. Most of the country was formed far after we were. So most of the sands do not have this collection of desirable properties that we have.
So can you actually see this story in the strata?
You can, yes.
You can, yeah.
Mm-hmm. Lots of places you can look at it. Actually, and I brought a book that I would highly recommend any of you interested in the getting. I don't know if any of you have seen this before. I believe there's one for Minnesota, one for Iowa as well. I'd have to double check though. This is a very great resource. It actually breaks Wisconsin up into its 5 major geologic regions. I'll send that around in case you guys want to write down anything. The driftless area, the northern highlands, the central plains, and then the 2 lake basins, Superior and Michigan. And it actually gives you basically field trips that you can do, self-guided field trips. It says, for example, drive along Highway 94, I-94. And then what happens is, in order to keep the road grade fairly even, engineers will actually blast out holes in hillsides for the road to go through. So you get big columns of rock on either side. They're called rock cuts. And geologists love rock cuts because they're pretty much an exposed area of Earth that they normally don't have the money to see otherwise. So they can go there and they can actually see what the history of a region looked like. So what this book does is it takes you on some roads that go through lots of rock cuts, and it has you stop at certain areas along the way, and it actually tells you what's going on in each rock cut. So it's a very valuable
Can I
resource.
ask a question? Is the quartz, was it ultimately, in the beginning, was it volcanic material?
The short answer is yes. The long answer is sort of. Quartz is formed as part of what's called Bowen's reaction series, which is a series of minerals that crystallize at different stages of magma rising to the surface. However, once volcanic rock is built up, it's ultimately eroded. And these quartz crystals most likely came from that erosional detritus that it was like just dropped there by any sort of volcanic activity. So it was a very roundabout way of getting there, but ultimately probably it was originally volcanic at some point in its life cycle.
Is it safe to assume that the craton that you're talking about here, with 500,000 years ago, prior to that existence as you're describing it now, it was also in existence before that, like 1 billion years and then 1.5 billion?
Yes.
So it had been going up and down and under the water?
It was very unsettled.
Mountains had been eroding and, okay. All right.
So going back before this time period, the very early history of the Earth was, of course, we actually started out as like an asteroid belt, like the one that sits between Mars and Jupiter. And what happens is the asteroids run into each other because they all have their own gravitational field, and then they stick together because that collision produces a lot of heat, which fuses some of the rock and metals in those asteroids together. And as you get bigger and bigger clumps, it has a bigger and bigger gravitational field, starts to draw more asteroids, and pretty soon after a billion years or so, you have a planet. The reason that we don't have a planet in the asteroid belt, they think, is because Jupiter's gravity was too strong to allow any of that accretion to happen. So anyway, once the planet finishes forming from these asteroids running into each other and sticking together, what you get is something really, really hot, because every collision, physically speaking, releases a large amount of heat. So you had hundreds and hundreds, if not thousands, or even possibly more like millions of collisions that happened. Yet all that heat was built up in that solid mass that would later become the Earth. What happened then was the Earth began cooling down, began settling. As the Earth began cooling down, it got more calm. The heavier materials sank to the bottom, or to the core of the planet where the center of gravity was. That's why Earth's core is mostly made of iron and nickel. And the lighter ones kind of rose to the surface, which is why, if you look at the density, most of the materials that make up our crust, which are, silicon oxides and aluminum oxides, those are lighter materials in terms of rocks. So what happens then is the Earth starts to cool down very slowly. And we end up with a very thin-skinned Earth for a large portion of history, where the crust was cool, but the inside is still very, very hot, sort of like an egg, except that it was not quite as fragile. But what happened then is you had pieces of these little puncture marks that would happen from extraterrestrial interference or whatever. You get cratons bubble up out of there, solid masses of rocks that bubble up and form these cratons, the roots of the continent. But the thing is that it actually took much longer for the Earth to cool, they believe, than it did for the oceans to form, stuff like that. So even though on the surface the Earth looked like it was pretty well settled fairly early in its history, the truth was that just below the surface, there's still a lot going on. So as that Earth was still cooling and settling, that would change the shape of it subtly, and that's what caused all this ocean fluctuation, all these cratons to bob up and down, stuff like that.
Excuse me.
Yes?
When did the atmosphere, when was it generated, and where did it come from, and what was the first atmosphere?
Atmosphere would have been degenerated once the rocks were kind of formed together. They start gravity would compress everything. So if you imagine like a sponge and you're squeezing out the water, that compression would actually squeeze out the atmospheric components from the rocks, which are what we call volatiles. It squeeze those volatiles out. They escape from the inside of the Earth out towards the outside, but the gravity held them in place. Atmosphere. But this was long before the sand was laid down.
Yes.
So anyway, then I'm not sure how much history. Do you guys get a whole lot of history on the actual hydrofracking procedure, or so kind of starting like the 50s?
Guys, time's up. We're going to be switching over. Finish up, whatever.
All right.
All she wrote.
Trying my best to distill everything down for you guys. I'm sorry if there's holes or anything.
How far can a horizontal fracking well go? How far?
9 miles is the
Long
record
ways.
right now.
9 miles.
Yeah.
And they don't have to get clearance for mineral rights if they're going
No.
outside there?
No.
Not even in the state of Texas?
It all depends on where you're at. The state of Texas lifted all mineral right restrictions in 1947 or 48. It was due to the conflicts that arose because they had sold off mineral rights on pieces of property during the pioneer times, and all records were lost. So just to make it easier for the companies, the Texas legislature voted to go ahead and ease all mineral right restrictions. But that's not the case everywhere.
Okay. 9 miles, huh?
Yep, that's the record at this point. I don't know that there are limitations.
And the depth? I've heard 17,000 feet.
It's, currently, there's actually a mine, an oil well that was test drilled in that went 5.5 miles. So, it all depends on kind of what they're after, how much they want to spend and what they want to do.
And what they can do.
Yeah, there's a great, if you Google oil well history, you'll come up with a couple of websites that really talk about that in depth. I can't give you a particular name of a site, but just poke around a little bit, you'll see.